Hi, welcome back. So today I'm starting a series of 2 videos where I'm going to discuss the conversation, the debate that I had with Socialism on left a little bit over a month now. And in this first video, I'm going to be covering the first of the 3 main topics that we discussed, which is the empirical strength of the labor theory of value. Now, in the next video, I'm going to be covering the distinction between productive and unproductive labor, which we debated a little bit, and also the theory of exploitation, which we also debated a little bit, and wage determination. So I'm going to argue basically that today's discussion is really going to be the most important because it's primarily what we want there to discuss, and also because it is the foundation for the other things. So overall, I think that the debate went pretty good, and I highly enjoyed the time that I spent there. And I sincerely think that Socialism on left seems to me to be a nice person, and he seems to have an open and critical mind, which is something that, as I've said in the past, I highly value. Okay, so we started the debate, and the debate began with me giving a short introduction of what the labor theory of value is and what it says. Now, obviously, because the time was scarce, I had to leave things behind, but overall I think that I did somewhat of a decent job. If you want to see a more complex and a more in-depth discussion, you can look at my last video where I discussed the same categories, only that a little bit, much more in detail. And in other videos I will be covering more the social processes behind these patterns. Okay, so Socialism on left seem to agree with my description of what the labor theory of value says and what it predicts, and we went straight ahead to discussing the empirical strength. Now here I think that I made the first big and probably the biggest strategic mistake that I made in the entire debate, which was beginning my discussion of the empirical strength of the labor theory of value with the cross-sectional hypothesis. Now this was a strategic mistake because had I started with the other 2 key hypotheses, which are the time series hypothesis and the structural hypothesis, we would have not been discussing too much one hypothesis without focusing on others, which we actually didn't even get to discuss, and we could have established from the very beginning that the labor theory of value has, at the very least, and I'm going to argue that not only this, but at the very least it has 2 highly corroborated hypotheses drawn from it. And the structural hypothesis, to summarize it a little bit, basically says that the structural element in the equation of prices of production, which is relative labor times, is basically of relative prices of production. Okay, relative labor times is basically going to be still the dominant element in the face of high changes in the distribution of wages and profits. Okay, now this was tested in a really ingenious manner by a really famous mathematician, really prolific mathematician from my university, from NYU, Jacob Schwartz, who actually went ahead and tested this hypothesis even before the work done on the cross-sectional hypothesis, and he concluded through his study that it is in fact the case that in light of big changes, okay, he looked at it through the business cycle, that in big changes in the distribution of wages and profit, the structural element is still labor times. So this is something that, had I started with this one, and Claudio Putti, by the way, who was a doctoral student at the New School for Social Research, he also extended Jacob Schwartz's procedure for testing this hypothesis using more data and bigger time spans, and he actually concluded basically the same thing as Jacob Schwartz had already concluded before him. And this is a highly corroborated hypothesis, predicted already since the time of David Ricardo, and only the labor theory of value seems to be the one that predicts this particular phenomenon, which is something that we actually observe empirically. Now, I could have also started from the time series hypothesis, which says that changes in relative prices are going to be explained primarily by changes in relative labor times, and this Anwar Shaikh, for example, in his book, in chapter 9 of his last book, tests this, and he concludes that it is in fact empirically sound. And none of these 2 hypotheses, the empirical test done on this hypothesis, could have been criticized from the standpoint from which he criticized the cross-sectional hypothesis, which is the one that I started with, okay? So if I had started with these other two, we could have already started from the ground that the labor theory of value has strong empirical corroboration. So I decided to start with the cross-sectional hypothesis, basically because I think that it is the easiest one within, obviously, the complexity of this topic, the easiest one to understand. And I didn't know, basically, what his criticisms were going to be. I didn't know what his position is. I didn't know anything because he hadn't told me beforehand. Now I had told him beforehand what my position was and what I believe is strong empirical evidence, but he never told me beforehand what his criticisms were going to be, so I obviously did not prepare specifically for those particular criticisms. So I started with that one, and had I known that he was going to attack the cross-sectional hypothesis from the standpoint of spurious correlation, I would have started with the other two hypotheses. But okay, this was a mistake, but still, I said basically that the cross-sectional hypothesis makes the prediction that there's going to be a tight relationship between prices of production and market prices, and between direct prices, which are prices proportional to labor times, and market prices. And I talked about empirical evidence provided by Shaikh and by, for example, well, primarily by Shaikh, but also by Ochoa, for example, and Sulfidis and Maniatis also show this. And I spoke specifically about the mean absolute weighted deviation and the measures of distance between vectors, between the vector of market prices, between the vector of prices of production, and between the vector of direct prices. However, right from the very beginning, he already started the discussion by speaking of spurious correlation, which already shocked me a little bit because I was not speaking, and I know that there is work that has been done using regression analysis, which I don't think that it is the best tool to use, and this is something that is going to become obvious throughout this conversation. And it is also something that, although I don't think is the best, I also don't think that it is invalid or that we shouldn't be doing that kind of research, even though I think that there's a better tool. Okay, but I'm going to explain that later. But okay, so he began directly with spurious correlation based on the work of, on the criticisms of Kleeman, of Nitzan, and Bichler. Okay, so let's focus first on Kleeman because that's the first author that he brought into the picture. Okay, so first, actually, let's talk a little bit about what spurious correlation is. Okay, so spurious correlation is a situation in which two variables or two events are highly correlated, but their correlation is not due to a causal link between the two, but actually to the effect. It's due to the effect of a third factor that is obscured in that particular correlation, and this third factor is the actual link that explains that correlation. It is not explained by those two factors alone. So a key example that is normally used in these discussions is the correlation between the amount of ice cream that is sold and the amount of deaths caused by drowning. Now there is a high correlation between these two things, and this is not due to a causal link that says that if you eat more ice cream, you're going to be more likely to drown. There's no causal connection, or at least there's no strong causal connection between these two things, because there's a third factor, which is the heat present in the air at a particular moment in time, that explains this particular phenomenon. Because in times where there is more heat, there's obviously going to be more ice cream sold because people want to eat more ice cream, and at the same time people are going to go more to swimming pools and the beach and places where they will be more likely to die of being drowned, basically. So this correlation, okay, would be and it is spurious. Now, speaking about our particular case, why do these authors think that there is such thing as a spurious correlation in the studies where regression analysis is used? Because again, there's a difference between regression analysis and the measure of distance, okay? And I'm going to talk about that in continuing with this conversation, okay? So they think that this is a spurious correlation because they point to a third factor, which they say is the size of industries as measured by their output. Okay, so industries with higher output are going to have more labor cost and are also going to have more sales in aggregate, and industries with lower output. Okay, so what this basically says is that it is a third factor, which is output, that explains the correlation in these studies where they regress price times output on labor values times output. Okay, so first of all, why is this done? Because well, I mean, even before we get to why this particular regression is done in this way, let's continue with Andrew Kleeman and the way in which he tries to control for this third factor. Okay, and the way in which he controls for this third factor is by deflating, as he calls it, by costs. Okay, total labor and non-labor costs. He deflates both variables, the dependent and the independent variable of that regression, by costs, and he finds that the correlation is destroyed. And he says, well, a legitimate correlation between prices and values would survive this deflation procedure, and it doesn't survive it, so therefore there is a spurious correlation going on in the studies, particularly the studies by Paul Cockshott and Cottrell. And so first of all, this procedure is mistaken, and it is actually misleading, as has been shown by Paul Cockshott and Cottrell in this particular study that you have in the screen, and also by Diaz and Osuna in these other two studies, the one that they did on 2005 and their 2007 study, as you have on the screen. Okay, so so basically, I'm not going to go into too much detail on why Kleeman's criticism, why Kleeman's deflation procedure is wrong here, because it's not even going to be that relevant for the discussion, and also because it is fundamentally wrong, and it has been shown to be wrong already here in YouTube by Paul Cockshott in his channel, and also in the studies that I'm obviously going to link in the description and that I already showed in the screen. So, so to get a basic understanding of why Kleeman's procedure is wrong, basically it is an ad hoc procedure because it deflates by one particular measurement of industry size, which is total labor and non-labor costs. You could have chosen other measures of size, and it is ad hoc because it basically artificially reduces the R squared. So what in regression analysis is the goodness of fit. It directly reduces it artificially by reducing the variability in both the dependent and the independent variables, exactly as Diaz and Osuna, for example, show. Okay, so Kleeman's procedure is not even that relevant, but we still need to take into consideration the potential problem of spurious correlation. Now, this problem, and this is something that I knew when I was listening from Socialism on left, his particular criticism. I already knew that in the original studies, because I read them, of course, I already knew that in the original studies there was a discussion of a potential problem in regression analysis due to the particular phenomenon that Kleeman, Nitzan, and Bixler then extend into a major issue that they say completely invalidates the empirical studies done on cross-sectional data. Okay, so I hadn't read, or I didn't really look carefully into Kleeman, Nitzan, and Bixler, primarily because I didn't know that he was going to bring those authors into the picture. So I didn't really know exactly what their procedure was, exactly how they thought that this was flawed. But I could already tell that this was exactly the same problem that was already noted by Ochoa, for example, in his 1984 paper. Okay, so basically the problem goes something like this. Okay, is if you take two vectors, okay, so if you take a vector of prices and a vector of values, and those two vectors are not correlated at all, and then you introduce a third vector into the equation, which is the vector of the outputs of the industry outputs, and you multiply each one of the vectors by industry outputs, you will artificially increase the correlation. So that is basically going to be what constitutes the element that creates the spurious correlation that we were speaking about. Okay, Now, Nitzan and Bichler, for example, produced this spreadsheet where they basically show this mathematical truism, basically. The Socialism on left presented this in our debate, you have in the screen, that they have some original values for prices and for values, and then they regress them, and they are random, so they shouldn't be correlated, and then they multiply them by industry sizes, and then they find that there is an increase, an artificial increase of the correlation. Now, this is mathematically, at that stage, this is completely valid, and this is something that Ochoa himself already noted in his 1984 paper. He said, look, if you have two vectors, A and B, that are not inherently correlated, and you multiply them by a third vector, then basically their correlation is going to increase, but this is going to be spurious, okay? And this is why precisely Ochoa already presented from the very beginning of this work, the notion of the measure of distance between vectors, okay? And so this is something that was already known, okay? And they controlled for it by looking at different methodologies, but there's also authors, Paul Cockshott and Cottrell, and Baeza, who actually basically took more seriously that particular set of criticisms, and they decided to argue against even the notion of spurious correlation. So Paul Cockshott and Cottrell argue that this is not a spurious correlation, because it forms a type of correlation where both of the two vectors basically serve as potential measures of industry size, and this is not really the correlation between one and the other doesn't really serve as the grounds for a spurious correlation. And they also show that when you run using the same methodology, when you run a regression between between prices times output on other inputs, for example, on they use agricultural products or on energy, that the regression produces R-squares that are far lower than the one that is produced by labor values. So basically this serves as and this is shown actually in many different papers, not only in Paul Cockshott and Cottrell, but it's also shown in this paper by Dave Zachariah, and it's also shown in this paper by Sulfidis and Maniatis. And this is basically a phenomenon that is observed, that labor values systematically produce a higher correlation, okay? So this serves as evidence against the hypothesis that this is actually a spurious correlation, okay? Now we're going to see why regression analysis could still pose certain problems. But even before we get there, we should speak about dimensional analysis a little bit, and we should look more carefully and criticize more in depth the procedure of Nitzan and Bichler particularly. Okay, so in dimensional analysis, and dimensional analysis, for those of you who might not know, is, you could call it a branch of mathematics that is applied basically to the study of natural sciences and also to engineering, but basically tells you how you should look at the mathematical relations between physical units. Okay, so there are three main features of dimensional analysis. There are three main lessons to be extracted from dimensional analysis, and we are going to apply them to this particular criticism of spurious correlation to see why there is no such thing as a non-spurious correlation, and there is no such thing as a spurious correlation in this particular case. Okay, so the first of these three key lessons from dimensional analysis is that in order for an equation to be dimensionally consistent, the particular thing that is on the right hand side of that equation and on the left hand side have to have the same physical units. Okay, then it must also be the case that when you add and subtract physical quantums, that they must have the same units. So you cannot add and subtract quantums of objects that don't have the same units. And then you can, in fact, this is something that you can do, multiply and divide quantums of objects that do not have homogeneous, that do not have the same magnitude units, okay? And this is relevant because in the demonstration of spurious correlation, what they are doing there is they're taking some numbers and they are calling them prices, and then they are taking some numbers and they are calling them values, and they are regressing them. And because they are randomly generated numbers, in the example of Nitzan and Bichler, they are not indeed correlated, but those numbers don't really have any meaning. But if you give meaning to those numbers, you suddenly find that the particular correlation that they are doing doesn't really make any sense. So to see why this procedure is really flawed, we can look at the equation that you have in the screen right now, which is that of the sample correlation coefficient between two variables. And in this case, we're speaking about price and value, so I'm naming them P and V. Okay, so as you can see in this equation, there is a mean, and you are subtracting both in the numerator and in the denominator each individual price by its mean and each individual value by its mean. Okay, now when you are doing this, you are assuming that you can in fact compute the mean, but this is something that you actually cannot do in a real case example, because these prices represent the prices of different units, of different physical units. So when you're adding up, when you're computing a mean and you're adding up all of the individual prices, you could do this if you don't give any meaning to the numbers, but once you give meaning to the numbers, this addition doesn't make any sense. You cannot add a table to a tennis racket, okay? So without obviously violating dimensional analysis. And this is why basically you cannot really have using input-output data or any type of data, a correlation between individual prices and individual labor times. The only correlation that you can have is that between the product of prices times output and between values and output, because then there is a consistency in the units of in the units, and then you can start to build a correlation coefficient. Now this also works for the R-squared in simple regression analysis. Now we are going to see how a model in simple regression analysis will look in next. But if you look at the R-squared, okay, which is also called the coefficient of determination, and you have the equation in the screen, you see that it is 1 minus the residual sum of squares over the total sum of squares. Okay, so these are concepts that you learn in econometrics, and basically this is how you look at them. Okay, so 1 minus the residual sum of squares over the total sum of squares means that you need to know the mean both of the dependent and the independent variable to compute the R-squared, because to know the residuals, which are the predicted residuals in a particular regression, you need to know the mean of the independent variable, and of course you need to know the mean of the dependent variable, especially if you're looking at the total sum of squares, because you see that it implies the difference between the dependent variable minus its mean, minus its average. Okay, so in constructing those averages, you're also violating dimensional analysis if you are doing regression analysis as well. So therefore, not only the correlation coefficient, but also the R-squared of a simple regression and of a multivariable regression, in case you want to add more variables to it, doesn't work if you put into the picture, if you bring into the picture dimensional analysis. Okay, so this is why there is no such thing as a non-spurious correlation, because you are assuming that you can in fact build a correlation between individual prices and individual labor times, when this is actually something that cannot be done. So Nitzan and Bichler, in their example, don't give any meaning to the individual numbers that they give, and that's why they can in fact build, they can in fact talk about correlation, but this is something that you cannot do without violating dimensional analysis. Okay, so the only correlation that can exist is that between the product of prices times quantities and between values and quantities. Okay, Also, what is another reason why that is the only correlation that could ever exist, and why there is no such thing as a non-spurious correlation to begin with? Okay, well, the reason is basically that market prices in input-output tables are by construction set to be 1 or 10 or 100 or 1 million. It's the most common, 1 million. So there is no deviation in prices, in market prices, by construction. So when you are looking at a regression between market prices and individual labor values, for example, there is no variation in the dependent variable. So you cannot do regression analysis because by definition what you're doing when you're doing correlation or regression analysis is measuring the covariance. So how does the variation of one particular variable correlate with the variation of another variable? And this is why you cannot really use regression analysis for measuring this relationship in individual terms, in unit terms, because it violates dimensional analysis, and because by construction market prices do not have, the vector of market prices does not present any variation between the values that are contained within it. Okay, so all of these are things that Socialism on left could have known if he had read the original studies, carefully read the original studies, because this is well shown in the very beginning. There is no natural measure of output in any industry, and thus there is a construction of the input-output tables in such a way that market prices show no variation. Okay, and to see that he could have in fact known this by looking at the original studies, let's go to Anwar Shaikh's 1998 study, and let's read a quote where he basically solves this particular issue by looking at what I presented to him as my preferred way of looking at the relationship between prices and values, which is the measures of distance, okay, of vector distance. And now I'm going to get to these measures and why they're better, and why there might be certain problems with regression analysis, even though, as we have seen thus far, the correlation that we're looking at is valid, and it is the only correlation that can be done. The only correlation that can be done is that between prices times output on values times output. Okay, that is the only one that can be done because of dimensional analysis and because there is no such thing as a variation in market prices. Now let's read a quote from the original study of Anwar Shaikh, where one of the original studies, where he basically shows this, and this is something that Socialism on left himself, had he read this more carefully, would have known. Okay, so let's read this. It is useful to note at this juncture that because input-output tables are cast in terms of aggregated industries, there is no natural measure of output for a given sector. One must pick a level such as, say, $100 worth of output in each sector, which means that the market price for this output is $100 for each sector. Such a procedure poses no real problems for the calculation of unit labor values or prices of production. But when comparing vectors, it does require one to distinguish between closeness of teeth in the sense of deviation, distance, between them, from the correlation between them. General measures of the proportional deviation between two vectors, such as the mean square error, root mean square error, mean absolute deviation, and mean absolute weighted deviation, are all line and give essentially similar results for this data. But the correlation coefficient R, or the R squared of a simple linear regression, are not meaningful in this case because by construction market prices show no variation and hence will show no covariation with the other vectors. So what is Anwar Shaikh telling us here? So he's telling us exactly what I have already said, and he's telling us something that I already told him in the debate and that he didn't really seem to understand, because at parts in the debate we seem to be speaking in past each other pretty much. Okay, so when I was talking about unit prices and unit in general and unit values, I was speaking primarily about the particular thing that Anwar Shaikh is talking about in here, whereas he was giving another meaning to unit, meaning individual prices of individual commodities of individual producers. And when we are talking about in this sense, when we're talking about units, and that is the sense that I was speaking about, is in terms of industry-wise. Okay, units industry-wise, and using measures of distance, you can actually measure the distance between unit prices of market prices and unit price of production and unit direct prices. Okay. Now, this is why I said that in the studies that I was referring to, which are the studies where the mean absolute weighted deviation in particular is used, or other measure of distance between vectors, that this is why I said in the debate that we are speaking about it in unit terms, not in the aggregate sense of the correlation, because the correlation can only be done in the aggregate sense of multiplying both of the variables by output. Okay. So then, what is the key lesson here? That Socialism on left didn't really understand, and that he repeated a mistake that he repeated throughout the debate. He thought, and this is something that also it's part of it is my problem, because I could have been more direct when speaking about this. He said basically that the mean absolute weighted deviation, for example, is also a measurement of correlation. But this is not the case, okay? When we're measuring the relationship between vectors, we can do so in two ways, okay? We can look at the covariation, at the co-movement between the vectors, and we can look also at the distance between the vectors. And this is the preferred methodology, for reasons that we're going to see. This is the preferred methodology by Shaikh, by Ochoa, by myself, and by other researchers. Now, Paul Cockshott and Cottrell and other authors have also used regression analysis, which I think that can still be used, as we've seen, but it is not, for me at least, the preferred way of looking at it, because I prefer to look at it in terms of distance between unit market prices and unit price of production and unit direct prices, okay? So this is really important to note, because spurious correlation implies correlation, and if we're not doing a correlation, we do not have the case of spurious correlation, even the potential case of spurious correlation, which is why we use these measures of distance. And this is something that I already told him, but he seemed to believe that spurious correlation also applies to measures such as the mean absolute weighted deviation, because they are also a measure of correlation. That's why he said, but they are not a measure of correlation, and spurious correlation doesn't apply here, and we are looking at it in unit terms. Okay, so then now we need to get to a potential issue, okay, that arises in regression analysis, which is included in Anwar Shaikh's in his last book, okay, which is why I prefer, and Shaikh prefers, and Ochoa, for example, prefers to use measures of distance instead of regression analysis. Okay, now this one is related, because this was already known from the very beginning, to the problem of including output in the regressions of prices and labor values, and it is related, but you will see that it only applies to the ideal case, where we would have all of the commodities, all of the industries that are included in the data set have the same homogeneous natural units, okay, of output, in which you measure output. So to see this problem, let's look at this original table. And this table is taken from Shaikh, okay? So the table itself is not taken from Shaikh. I constructed this table myself, but the numbers themselves, the numerical example is indeed taken from Anwar Shaikh, from his book, from chapter 9 in particular. And here we can see, so in his table, he has more variables. But I think that with these variables, we can simplify it a little bit, and we can still get the gist of where we're speaking about. And here we have 3 industries, okay? And we have prices, which are denoted as PI, values, which are denoted as VI for each industry, quantities, so output quantities, which are measured, which are here named Q, and then we have the product of prices times output and the product of values times output, okay? Now, in this table, you can see that originally, if all of these, let's say all of these, the prices and the quantities reflect the same natural units. So, for example, Anwar Shaikh here is talking about tons, okay? So if all of those commodities in those 3 industries could be measured in tons, okay, and then we set that to be the unit of measurement, tons, then we could in fact do regression analysis in this case, because it doesn't violate, because we are speaking about tons, it doesn't violate dimensional analysis, okay? It doesn't violate what in the other examples would have been violated, okay? So if all of these industries, the output and the prices reflected the prices per ton and reflected the output measured in tons, then and the values reflected the amount of labor time that is required to produce a ton of those commodities, okay, of those three industries, then we could in fact do regression analysis, and we could do a correlation, okay? So in this case we have two models, okay? We have the R squared of a first original simple regression model, which is the regression between individual prices on, so the vector of prices on the vector of values, okay? So here, this is the equation, as you can see, this is the equation for a simple linear regression. So there is a slope parameter, there is the slope parameter here is beta 1, then there is the intercept parameter, which is beta 0, and then there is this omega here, which represents the error term, okay? Now you can see that by construction, okay, so these numbers are said in a way that there is a high correlation between prices and values, okay? So there's a 93 or 94% R squared, which says that 94% of the variation in prices can be explained by the variation in values, okay? So this is a high R squared, which is indicative of a strong relationship between these two as measured in regression analysis. And if we look at the R squared of total prices, so prices times output on values times output, you will get a slightly higher R squared, that of 0.93 and 96, okay? So in this case, what we see is that output does in fact, as we've said, in the case of spurious correlation, add some more explanatory power than if you look at it in unit terms. But in this case, prices and values are already individually highly correlated, okay? And this is if we could do this, if this could actually be done, if all of the industries' output could be measured in a natural unit, like tons or kilograms, the labor theory value would in fact predict that this would be the case, that there would be a higher squared between individual values and individual prices, okay? Now, what this says basically is that output in fact adds only a little bit. So the labor theory of value would still hold in this situation, even if there is a little bit of explanatory power that is included by output. Now, let's imagine that we change the way in which we measure output, we change the units, and we change them from tons to bales, okay? So here in the screen you can see that if we transform the measurement from tons to bales, and there are 2.56 bales in 1 ton, then we can see that we should transform all of the individual prices, values, and outputs of each individual industry in the following manner. So we should multiply quantity by the original values, we should divide both prices and values by the original values, and then we will get the transformed prices, values, and output in terms of bales. Now, you can see that, and you can see here in the table also, that the total product between prices and quantities, and between values and quantities, is not going to be altered. And it is not going to be altered because these totals are what we call unit free. So they are not in fact transformed by a transformation of units, okay? But prices, values, and quantities are indeed transformed, and this is why we are interested in seeing what happens now. So in this ideal case, where we could in fact measure everything using the same units, so there is no variation, by the way, in this transformation. It's set in such a way that there is no longer a variation in the independent variable, so in values, and thus there is going to be a 0 R squared, okay? So if you look at a 0 R squared in the first model of regression individual prices on individual labor values. So if this is the case, then we could come to the conclusion that there is no explanatory power basically by the model, and that is because there is no variation in values. But if we bring back the total, so if we bring back the regression of prices times output on values times output, then we will get again the same r squared of 0.96 that we got in the non-transformed table, and this is because again they are unit independent, they don't depend on units. So here the implication would be that now we could explain all of the explanatory, so all of the explanatory power would be added by and this is, by the way, an example that I spoke about in the debate, but here you can have the numbers. You explain the entire thing, okay, so all of the explanatory power now is added by output. So in this ideal case, we could see that the problem of using regression analysis could be that it leads to certain problems in interpretation, because in the case where there is no relation between prices and values, output would include a lot of the explanatory power in this case, but if they were already highly correlated, they would add only a little bit of explanatory power. And because using input-output data we would be incapable of discerning the individual contribution, so the contribution of the individual prices and the individual values, we could only use the totals, because that's the only regression that could be done. Even in this ideal case, using actual input-output data, then we would have a problem, which is, because there's no variation again in market prices, then the problem would be that we wouldn't know how much of an addition of explanatory power is due to the total outputs. So this would only be a problem in regression analysis in the ideal case, because as we've seen, regression analysis can still be done, but it can be done only in the case of total prices times output, so prices times output on values times output, okay? So then the problem is that there could be, in this ideal case, a lack of understanding of where does the explanatory power come from. Does it come from primarily from from the individual regression, from the individual correlation, or does it come from the output? So in order to get rid of this problem entirely, what Shaikh and Ochoa do is they look at the measures of distance. And here, in the field of the distinct measurements of distance between vectors, there are quite a variety of measurements of distance that could be employed, which is why we need to set a criteria for what would be an ideal, for what would be the best possible measure of distance between vectors that could help us test the difference or the closeness between prices of production, between market prices and between direct prices, which again are prices that are proportional to labor times. So they are prices that embody the, let's say, the perfect labor theory of value, where there is no systematic deviation of relative prices from relative labor times, in this case caused by different organic compositions of capital between different industries, okay? So all of this, okay, is it's quite dense and it's quite complicated to understand at an initial level. So that's why in other videos I'm going to be getting into much more detail into these things. But okay, so for now you need to stick with me and you need to believe what I'm saying, basically, so that I don't have to get into too much depth. Although again, in other videos I'm going to be covering these things from a more simple perspective, okay? So the measure of distance that we should use, okay, and now I'm going to cite Shaikh once again, should have a set of properties that are ideal, okay? Now, what are these properties? So if we read Shaikh again, if we read his, in this case, his last book, his 2016 book, chapter 9, we will see the following thing, okay? So he says the three qualities seems desirable, and here he's speaking about the measure of distance. It should be invariant to the general changes of units and to the scaling of the vectors. It should be weighted so that large deviations in small industries do not have an undue effect on the average, and it should possess some sensible properties and an intuitive meaning. Okay, so Shaikh basically is giving a set of criteria, and he outlines a wide variety of measures that could be used, and he basically concludes that the classical measure of distance and the mean absolute weighted deviation are pretty much the same, that they yield pretty much the same result, and that they are both good. And he also says that there are others that could be good. So let's start from one that is a little bit more simple and that is not entirely good, but this is helpful to understand the one that is actually good. So let's start with the mean absolute deviation, okay, the math. So the mean absolute deviation basically tells us, and this is again why I say that we're doing it in unit terms, and this is why throughout the debate I said that we were doing it in unit terms, because we're looking at the difference between unit prices from direct prices, okay, and from prices of production. So if PI here denotes market prices, unit market prices, and P prime I denotes direct prices, which are prices directly proportional to labor times, the math, so the mean absolute deviation, would basically tell us, and by the way, this is consistent with dimensional analysis, because as you can see, you're taking the difference between prices that reflect the same units, whatever they are, they reflect the same units, and you're dividing it by the market price. So you are getting, in this sense, something that is not going to yield a problem when you add them up, at least using dimensional analysis, okay? So then, we remember that prices are set by construction, market prices are set to be equal to 1, for example, right? So if they are set equal to 1, what you can see here is that for example, if the price, market price is 1 and the direct price is 1.7, that the mean absolute deviation in that particular price, so without taking any other industries, in that particular price would be of 0.0, so it would be of 7%. All right, okay, so it would be 1 minus 1.7 over 1, okay, times 100 in this case. So if we add up all of the deviations and we divide them by, in this case we divide them by the sample size, then we will get a number that will tell us the mean absolute deviation, okay, in a particular sample of industries. Now, this measure of deviation is not the best one, and it's not the best one because it lacks a fundamental property, which is that of having weights controlling for the undue effect that some industries might have on the total if they are too small or too large, okay? So that's why we use the mean absolute weighted deviation, and the mean absolute weighted deviation is really similar to the mean absolute deviation, only that it includes as a weight the output over, so the share of a particular industry's output on the total. So that's why we multiply the deviation of each particular market price from its direct price by quantity over the sum of all the quantities, okay? So this is the mean absolute weighted deviation, and this measure is ideal in the sense that it meets the criteria that Anwar-Said sets. And now there are other measures of distance that also meet this criteria, and as Anwar-Said shows, they also produce small deviations in cross-sectional data, okay? So using all of these measures that are ideal, we can in fact test in a rigorous fashion the cross-sectional hypothesis by looking at the difference between market prices, direct prices, and prices of production, okay? Now, the labor theory of value predicts that these differences are going to be very small, and they are indeed small. And this is something that is uncontested, okay? This is evidence that is shown for all of the studies. Now, there are certain studies that don't show a really tight relationship, but those have a certain problems of their own. But, okay, but in the main studies, okay, in all of the studies, basically, this is the relationship that is shown, okay? It is a tight relationship as measured by the closeness between direct prices, market prices, and prices of production. And the labor theory value predicts that this is going to be the case. And this was uncontested throughout our conversation. Now, there could be something levied against this particular methodology, which is saying that, well, the aggregation within an industry produces a damping effect. So it artificially reduces the distance between vectors. But this is something that doesn't really apply in this case. First of all, because different studies have different industry quantities of industries, so different input-output data, different input-output tables for different countries have different levels of aggregation, and within the same country there could be also different levels of aggregation, and in different levels of aggregation this has been shown to be correct, and also because the process of aggregation is more complex than what some people might propose. So the mean absolute weighted deviation is, for me and for Anwar Shaikh and for other researchers, the best of the different methodologies that we could use to test the cross-sectional hypothesis, the best for our particular purposes. And the studies show that using this methodology, there is indeed a good relationship. So all the way until now, we have established the following, okay? We have established, first of all, that there are other two hypotheses produced by the labor theory of value which have been shown to be empirically well corroborated and to which no criticism relying on the spurious correlation or pretty much another thing could be levied against them, okay? So they are empirically well supported. And then we have come to the issue of regression analysis of the cross-sectional hypothesis, and we have shown that regression analysis could only be done in the sense of the aggregates of prices times quantities and values times quantities, because other correlations in terms of individual terms in the actual output data, the input-output data that we have, cannot be done mathematically because they violate dimensional analysis, because there is no deviation in the vector of market prices, okay? And we have seen that even the correlation of total of the totals produces a good, although not the best, method for testing the cross-sectional data, okay? Now, the cross-sectional hypothesis could be tested in a different way that does not have this problem of spurious correlation and that produces what I think are more consistent results, which is measurements of vector distance, and in this case, using the mean absolute weighted deviation and other ones, we have indeed small deviations, okay? So this is what we've established so far, that the labor theory of value is empirically well supported on different grounds, on different countries, on different years. So this is something that really cannot be contested at this point. The overwhelming majority of the empirical data, of the empirical studies done on this issue, support the empirical strength of the labor theory of value. And this is something that is these are things that are only predicted by the labor theory of value. So as far as I know, there are no other theories that have this same structural hypothesis, time series hypothesis, and cross-sectional hypothesis. And this is something that we didn't get to discuss, but I would have liked to know if socialism on left had a better theory, in the sense that it could explain the observed phenomena and at the same time include more explanatory power, and at least show that what we are arguing is incorrect, that the labor theory of value is incorrect in some sense. But this is something that socialism on left never tried to put forth something alternative. He spoke throughout the debate about modern economics and things like that, but he was never specific about what he meant by modern economics, because modern economics has different schools, different ways of doing economic analysis, and I don't really know what he meant there by modern economics, but even though he seemed to venerate, for some reason, modern economics. Now, I as well think that modern economics is important, because a lot of the studies and a lot of the phenomena that I'm studying is also based on modern economic phenomena and on modern methodology. But of course, I belong to the classical tradition, because I think that the beginning of the arguments that help us understand modern phenomena and that serve as the foundation for the modern developments are in the classical tradition and in the Marxist tradition and their subsequent developments, okay? So socialism on the left really never tried to give that. So what exactly, and this is a question that I would throw at him, what exactly does he present that explains the same phenomena that the labor theory of value explains more or that it actually shows that there's some problem with the labor theory of value. Okay, so in the next video I'm going to be covering more of his criticisms, and I'm going to be covering other topics, but I think that for now this already serves as a good discussion. Okay, as a good discussion. It's probably, this is a pretty long video. Okay, now my conclusion is basically the following: is the labor theory of value is indeed empirically well supported, okay, and it serves as a good foundation for other theories that are also empirically well supported, and it is also theoretically sound, as I showed in my last video, and as I'm going to continue arguing in the next video, of course. And Socialism on left here really had isolated points that he threw here and there, but he doesn't have a cohesive system from which he can attack the system that I defend, and he doesn't really have anything better to bring into the picture. And of course, his criticisms are ultimately unfounded because they're based on the methodology of Kleeman, of Nietzsche and Bichler, which has been shown to be inappropriate and inaccurate for the purposes that we are trying to study. Okay, so there's no such thing as spurious correlation, once again, and we're not even using, at least I am not using regression as my primary method for testing cross-sectional data. And I think that Socialism on left could make use of more research on the original studies and what they said and why they were already including this potential problem, the way in which I've shown, and why this only works for the ideal case, and why the methods that are used currently and that have been used already for some time by Shaikh, Ochoa, and others are indeed accurate and are indeed well, the appropriate methods for testing what we're trying to test. Okay, so I encourage him to do more research on this particular topic, to look more carefully at Sheikh's work, at Ochoa's work, and so on. And I will leave all of the sources, the ones that I've cited and even the ones that I haven't cited, in the description, so you can look at pretty much all of it. And any questions that you may have, of course, you can always ask me. And well, I mean, this is pretty much it. I don't want to extend this too much. So with that being said, I hope you all have a wonderful week, and I will see you in the next video.